Hey, hi Omshi. So,
Hi.
yeah, thanks for joining. So, I'm just going to start right now. Yesterday, we have seen some introduction about how the servers were evolved from individual machines to virtualized VMs and VMs to cloud, from cloud to now the Dockers or containers. Okay, a container is something a running instance of an operating system. Okay, an image of an operating system. That's it. So typically, a container we called as a runtime object. Okay, and a container can be executed or run, okay, only if you have an image, okay, and those images yesterday's session, we try to download from the Docker Hub. Okay, you might be seeing the website yesterday, Docker Hub. Okay, so this is a website where once you install a Docker engine, right, it by default comes to this Docker Hub and downloads whatever the image you want it. Okay, and you can find here two types of images here. One is the official images and another is the public images. So what exactly official images? See, when I say Ubuntu or CentOS, okay, suppose when I search for CentOS, right, okay, uh, just click on this. Last updated 2 months ago. You can find something I'll show you how it looks like. Can you see this official? Yeah, this is what I want to show you. One is official repositories, another is the public reports. What do you mean by official is the company who, the organization who develops the CentOS operating system, right? They own this, okay, and they release the official version. Nothing but you can trust it, okay. You can download this and you can work on it. So apart from this, people like you and me, we can download the CentOS from this official and we can tweak a bit and we can put something our own stuff and we can upload it, guys, okay. And these will become your name and the image sent to us, this is kind of public ones, okay. So these are all the public ones, but always go to the official ones if you want to set up something and all. And you can see how many downloads are there. Downloads, I think, what pulls 10 million pulls for the official, but look at for the rest of them, okay, the very few, because these are developed by you and me, like any person. Like we will also upload some images over there. So an image is nothing but is kind of a metadata of an operating system. It's a file, actually. It's a flat file, okay. And in a Docker container, right, okay, so this is what your Docker instance, okay. Sudo docker ps hyphen ps. If you run ps, right, it will show you the running containers, okay. Right now it is running two containers, okay, with the base image of CentOS is one, Ubuntu is one. These two we ran it yesterday session, right? So I didn't shut down my machine, so it is still running. Now if you wanted to see what all the images available in this machine, okay, you can see uh, with the sudo docker image you can find all these images. So I have Ubuntu and CentOS images. So now these are all regular official images which we download from the Docker Hub, okay. If you want some other images also, you can download from the Docker Hub and you can just start working on it, okay. Now you can launch an image n number of times. Nothing but if you try, see, look, right now CentOS is already launched, okay. I wanted to launch another I want to launch another container with the same CentOS image. You can launch it, okay. So that for that you have to run a command called docker run, okay, CentOS. Can you see this? Sudo docker run -t. CentOS is my base image, it nothing but interactive, and the I wanted to open the bash shell prompt, okay. So that's it. It's opened another instance now. Now if you want to come out to your prompt, now you're in a new image, so within few seconds it launched a new operating system, okay. But this is what your container ID, whatever you see it here, okay. And if you want to come out, control PQ, okay. So now you are in your prompt. Now you check sudo docker ps. You can see three containers are running. Can you see this? This is just now 23 seconds ago you spinned up, okay. And this is running with the base image of CentOS. Okay, this is how you can spin up a number of containers in a single machine with the help of the Docker engine, okay. So till here, you should get an idea what is an image, what is a container. Remember, there are only two important things in Docker. One is an image, one is a container. A container is nothing but a running instance of an image, a shortcut, okay, is a running instance of an image. So what exactly an image is? It's a metadata or a static file of an operating system. Okay, so a tiny operating, when I say operating system, it's not a big operating system, it's a, like in a core or bare operating system. Very little features will be there. Okay, if you want more, then you have to install on top of the operating system. So this is an image is nothing but a flat file or a static file. Okay, and that's like a, an object actually. Okay, which is not which won't give you anything until unless you run it in a, when you run it, then it will become a container. Okay, so example I would say, so I hope most of you guys in Java language, like instantiation, right? Okay, if you have a class, you can create n number of objects. You might be remember this concept. Okay, so I have a class A, so you can create like n number of objects from that class, right? So these objects are something like a containers, and the class is like an image, guys. Okay, so class, there is no use like directly. You have to create an object, then you have to make use of the objects. Object is like a container. Okay, so the container is useful for us, but you cannot get a container unless you have a image, guys. Okay, so class is like an image and object is like a container. So that's how you can understand in your other way of like learning. Now, so let me note down a few commands. Okay, docker images will list down all the list of downloaded images. Okay, and docker ps will display the running containers. Okay, and again there is another command, ps-a will display the history of containers. What do you mean by history of containers? Is, see, if you try to run ps-a, it will show you from yesterday what are all been running. Okay, so we started a couple of containers and we exited. Can you see this? These three exited nothing but we started and like we exited, and these three are running at the moment. Okay, suppose if you wanted to like stop a running container. Okay, so this id is there, right? Can you see this container id? So this alphanumeric digit, this is called a container id. Okay, so you can stop a container with the help of like the id. Okay, docker stop. Now it is getting stopped, that container, guys. Okay, it's been stopped. If you want to cross check, try to run sudo docker ps command. Is it running? It's been stopped now. Can you see D512? Is it running here? It's not there. Only two are running. Earlier there were three actually. Can you see this? There were three, right now only two. So it stopped. So now if you try to run the docker ps-a, you can see this has been exited like few seconds ago. Okay. In case if you wanted to start this container, you can run sudo docker start and you can take the container ID. So what happens at this point of time, this is not a new container, guys. It's the same container we are starting now actually. Okay, now it's been started. If you want to cross check whether it started or not, you can see, can you see three containers at the moment? Okay, and if you run the ps-a, you can see the history, like this container like came back up and running at the moment. Okay, this is not a new container, this is an existing container. You're trying to like start it again. Okay, and one more thing, there's one more command is there. Suppose this container is running now. Okay, you want to get into the container, get into the container, nothing but you want to log into that image. Okay, that container inside the container. So what you can do, sudo docker attach and take the container ID, and you will get into the container. Now you are inside the container. Can you see the prompt now? Root and container ID. Okay, this is a container. You are inside the container now. Okay, and again, whatever the data you created here, okay, anything, whatever you do it here, everything will be like symlinked or voluminized to your main host machine. Okay, where exactly to store the container information, I'll show you. Just try to exit this. So when you exit, right, so it will actually exit your entire container. Okay, if you want, you can check it out. Sudo docker ps. Can you see only two containers are there? The other one is exit and nothing but you already opened a bash prompt. Now when I say exit nothing but you are trying to like stop your container also. Okay, so that's the reason it's been exited. There is a location called var lib docker. Okay, so let's say sudo. Where am I at the moment? Okay, sudo ls. Sudo ls -. Can you see this? This is what this is your host operating system. Okay, now get into the containers containers. Let's log in with root, guys. Can you see this data? Okay, so this is it's a directory actually. Okay, if you get into this directory, this is automatically created by your Docker engine. Okay, and if you get into that, you can find, like, your data. Okay, what's been, like, you are doing your container data. Okay, what is your container configuration, how it has been created, so everything, it will be there inside this. Okay, if you want some information, you can come over here, and if you try to delete that, you will lose your entire container data in case you open your container. Okay, so exit, just come back here. Let me note down all those commands what we ran over here. So docker start container id. So with the help of this, you can start a container. Okay, and once it's started, docker attach container id. So if you do this, what is happening, you can logging in inside the container. Okay, this is what the command to logging in. And before all these things, I wanted to show you docker run -it CentOS. Okay, and you wanted to launch the bash, shell from. Okay, so this is, like, launching the container, launching nothing but running. Okay, container from an existing image. You might be thinking, suppose if you don't have an image, what will happen? If you don't have it, it downloads from Docker Hub. Okay, it downloads from the Docker Hub. Right, that's how it works. Suppose if you want, I can show you one more example. So we have seen yesterday, where is it? Yeah. We have seen CentOS and Ubuntu, right? Let me see, like, I wanted to download some other containers. So let's go to the Docker Hub and check it out. RHEL. Let me call it as a Red Hat. Okay, I don't have any Red Hat specific official ones, but what I can do, I can try some. Okay, let's see this. Copy this, sudo docker run -it paste that. Okay, and bin bash. Look at this. This image is not existing in your local. Okay, in your local machine. So what it is doing, it's trying to download from the Docker Hub. So it is trying to download the image. You might be thinking why it is downloading so many images. Okay, I'll give you the story behind it later, but right now understand, it is actually trying to download whatever the image you mentioned. Okay, which is something like, what is it, HJD48, something like that, blah blah. Okay, so it takes some time, guys, because first time it tries to download from the Docker Hub, but second time when you try to launch any other container from the same image, okay, it makes use of the local image, whatever is downloaded, just like Maven local repository, guys. Okay, once the library is downloaded, it makes use of the local, right? So same thing. So where am I? Okay, so it downloads from the Docker Hub, right? Attach. Okay, and you can stop docker stop container id. Okay, so that's how you can play around with a container. Okay, now come back to the images. Okay, so image is something like, a metadata or a static file of an operating system, something like in a flat file. You treat it like a flat file or some exe kind of stuff. Okay, so this image will help Docker engine to spin up a container. Okay, with the help of image only, it can bring up a container, right? So the list of images in your machine, you can see with the help of the Docker images. Okay, and every image, okay, will be having an ID. Okay, I'll show you how it comes. Okay, this seems to be done. Can you see it's been inside now the container? Okay, so just exit, guys, and now you do the sudo docker ps-a. Can you see this has been just exited, this image? Can you see the image? And now you try to run a sudo docker images. Can you see the other image as well from the Docker Hub? It's been downloaded now. Okay, right. So these are all images, and every image will be having an image ID. Just like a container is having container ID, images will be having image ID. Okay. And again, before proceeding with images, let me complete the container stuff. If you wanted to delete a container, okay, it's pretty easy. Docker rm, and you try to provide the container, guys. Okay. So try to provide this container ID. Okay. Now the container has been deleted. If you want, you can cross check it. uh, is it there, guys? It's been deleted now. Okay. And remember, you can delete a container only when it is stopped. Okay. So suppose, can you see this container sent voice is running? Can you see this up from 23 hours? So try to delete this container. What will happen? We'll see. Sudo docker rm, the container id, it will throw an error because it's a running container. First you stop it, then you try to delete it. Okay. If really wanted to forcefully delete it, you can make use of -f. That is not recommended, guys. Never remove that. Try to stop a container and try to remove it. Okay. Let me put this command as well. Docker rm container id, make sure the container is stopped. Okay. Just a second, guys. Okay, sorry guys, I got a call. So where am I? Images. Now every Docker image will be having an image ID. Just like a container is having a container ID, images will be we have images, and images will be having an IDs. Okay. So in the backend, how exactly an image is made is, open a paint, control I, don't see it. So it's something like a stack. Okay. So let me try to explain you. Layer 1, layer 2, layer 3. So how actually in the backend the image are built is, we will be having a core image, guys. The core image hardly will be something like, some 50 MB to 100 MB, not more than that. Okay. This is a core OS actually. Okay. Suppose I assume it is a CentOS OS operating system. Okay. So the core OS will be having this. On top of it, if you want to customize an image, and you wanted to give a Tomcat server, or you wanted to give a WebLogic server, or you want to give a Jenkins server, right? So what we'll do it, we'll install JVM or Java. Okay. And when you install something, right, the state of an image is gone now. Okay. So it treats like a new image. So the layer 1, the first image is having some alphanumeric number. Okay. And when you do some changes on it, it changes your entire state of your base image, guys. Okay. So when it changes a state of base image, it will be having another image ID. Okay. Similarly, you install Tomcat on top of it. Okay. Then again it will be getting another image ID. Okay. So this is how a stack of layers of images will be binded together. Okay. And given as a single image. Now when you downloaded when you try to download this new image, right, from the Docker hub. Okay. When you look at this, when you try to download this image, right, you might be seeing there are so many other images are downloading in the backend. Okay. See, these are all the images are download backend. Why these are all download backend? Because the main image is the last one, 97 D99, that you can find it in your images. Okay. Where is your images? D758, right? Look at this. It should be the last one or first one. Can you see that anywhere? You don't find it? The image ID. sudo docker images. This D7852422DC65. To prepare this image, it will be having a stack of some other base images. Okay, those are all will be downloaded at the time of runtime. Okay, but only it will show you the base image, but actually it should show while it is downloading. Okay, if it is not showing here, we can just find out in another location. So the other location is var lib docker. We should be a sudo user to do this. Images. Let's get into the sudo, guys. Su var lib docker. Can you see images directory here? Image, yeah. Device mapper, distribution, no. Image db, metadata, no. Let me Google it. I didn't remember exactly the path of it. Docker images location and CentOS. How do you change? How to change the Docker image installation directory? Where it is deploying? Var lib docker containers. Okay, but can't find the images. Var lib docker. He is also looking for the image directory. Driver name will contain the driver specific contents. Device mapper. Graph. Okay. CD. Not having any graph. No. Device manager. Metadata. No. I'll do one thing. Find. It is a directory actually. For every operating system, the location is different. Okay, forgot to tell you one more command. There is another command called docker info. Okay, so with the docker info, you can see how many containers are running. Okay, and how many images are there. Can you see this? Total number of containers are 6. Okay, and there are 3 images are there. And can we find that image location from here? Metadata loop. Everything should be there inside this var lib docker directory only, but I'm looking for like now the exact path. Where can I find that? Device mapper, device mapper, metadata. Oh, it's a file. Cat metadata. Sorry. Okay, guys, let's forget about this. I'll check it out what exactly the path, because I checked it in the Ubuntu. It's a different one. Am I having that location? I think I have not noted that, but there is a separate path. Okay, just for information actually, you don't have to worry about it. Okay, where exactly it will store, but somewhere in your machine it will store all the images. Okay, the stack of images. So yeah, once image is done, now the actual stuff is like, okay, how do we prepare our custom image? Okay, so and once I prepare my custom image, how do we store that? Okay, so to prepare your custom image, you have to depend on something called Docker file. Okay, so with the help of the Docker file, what you can do, you can prepare your custom image. Okay, and if you want to learn about the Docker file, this is what your Docker scripting, guys. Okay, so how a custom image has been made. Okay, so to work with this Docker file, right, so first try to create a directory. What is my machine? Okay, here. mkdir. Let me say, like, I wanted to create a directory called Apache. Okay, get into the Apache and try to open a file called Docker file. This is like your pom.xml, guys, in Maven. Okay, try to open this, and the Docker file starts with a command called from. Okay, from nothing but what is your base image. Okay, if you look at this diagram, right, see, right now this is somebody did it. Now you will be having some base image. Okay, on top of it you will be doing it. So my base image at the moment is sent voice. Okay, so right now my base image is sent voice latest. What do you mean by latest? Nothing but the latest image. Okay, so I wanted to, like, prepare my my custom image from the sent voice machine. Now once you have that, you can write about yourself, maintainer. Okay, maintainer nothing but who is going to maintain this. Okay, myself. Try to provide your email ID. Okay, gmail.id.com. Right, now once this is done, okay, then actually now on top of your base image, what do you wanted to do it? Okay, so this is where a run come into the picture. So what exactly a run is, what do you wanted to do it? Okay, I wanted to install, okay, install HTTPD, which is Apache. Okay, I want to install the Apache software, Apache web server. So what is the command to install the Apache software, guys? You may install HTTPD, right? You provide -y, it will not ask you yes or no, and okay, that's it. So if you run this, right, what will happen? It will start an Apache, right? Then apart from run, okay, so when you install Apache, right, it will create a layer here. Okay, one layer it will create it, and it will package that as a new image, and this will be having another image ID. Okay, next, once this is done, okay, next step, so once your Apache install, right, you need to start that and you need to get a port open, right? So there is something called expose. Okay, I wanted to open a port called 80. Okay, within this message, so this port will be open to the external nothing but from this container it will be open, within the container it will open 80 port for HTTPD. Okay, but if you want to open to the external world, you have to provide that port at the time of runtime. Okay, now expose port 80 nothing but Apache port, I'm trying to open it on the 80. Next, once this is done, CMD. Now the next thing is you want to start your Apache HTTPD, right? How do you start your Apache HTTPD? Okay, so typically we need to, like, provide a command. Let me show you how do we start Apache, guys. Let me see it in my machine first. I forgot the command. Sudo etc init. I don't have Apache. Okay, I'll do one thing, guys. I'll first experiment that command over here. Okay, so sudo yum install HTTPD. I'm installing HTTPD in my host machine because I wanted to know exact commands, so that those commands will run in your Docker image. Okay, now it's been installed. So to start your Apache server, sudo etc init HTTPD. Okay, sudo service HTTPD start, or this seems to be this one, HTTPD service. Okay, copy, paste. So, okay, this is started. If you want, you can cross check whether it started or not. Status. Okay, this seems to be active and running. Okay, this has been started now. Okay, so if it is really started, you can cross check whether you could able to launch that port or not. I mean the Apache or not. This is in your host machine, guys. I didn't run the container yet. I didn't run with the base image yet. So what is my IP address? IP address Ethernet 1, Ethernet 1, Ethernet 1, 192.168.27. Copy. With 80 port, yeah, this is what your Apache. This is running. If you try to provide 80 or don't give it 80, anything is fine. Right. So what is the command, guys? This is start. Take this command. Okay. Now open your Docker file. Okay. So in your command, what you're supposed to do, try to provide that command. Okay. So with this, what will happen? Your Docker will start. Now when you run the image, right, okay, when you run the image as a container, it will start and leave it. It will not it will not stay running. okay, to stay running your container, you try to like hang on your prompt. Okay, so for that what I can do it, I can write a while loop. Okay, while true, okay, I need the syntax of it. While true, do sleep 100, done. This is infinite loop. Okay, I just want this, guys. While true, docker file, paste it. Okay, I'm done with my docker file, guys. So now it's a time to like build an image. Now with the help of this file, I'm going to build my custom image. So how to build my custom image? Sudo docker build is an option. Okay, and -t it is, I think it's interactive something is there. Let me look at my notes. -t something was there. Docker build. Did I provide anything to build? T build -t. Okay. Okay, T nothing but specify the name of it. Sorry. So when you're preparing to an image, right, you have to provide a name to your image. So I'm providing, my image name is Apache, and you can provide a version as well. So I want to provide a version called 1.0. Okay, so yeah, now from where you wanted to prepare your image. Okay, so dot nothing but it will take your docker file from your current directory, guys. Can you see this? It is preparing an image. Okay, so step 1 from CentOS. Okay, it is trying to pull from the CentOS, pulling reported docker CentOS latest image, CentOS latest not found. So it says like it is not found. I think we gave something wrong. It should be CentOS colon latest, not slash. Okay, right, it bought the CentOS latest, guys, and maintenance Chiranjeevi. Okay, and it ran yum install y. Can you see this? It ran the httpd as well. Okay, right, so it's been installed now. httpd is installing in my image. Okay, so it's preparing my image, guys, with my custom image with the httpd software install. Right, so once it is prepared, now it is exposing a port 80, and once the port 80 is installed, like it is starting my Apache server. Okay, and that's it. My base image has been successfully created. If you want to cross check whether the image is created or not, sudo docker images. Okay, guys, did you observe this Apache 1.0? This is my custom image which I prepared now. Okay, so this is nothing to do with my like a Docker hub and all. Okay, now when you prepare a custom image, okay, so okay, are we still running this Apache? Okay, let's try to stop the Apache in my host machine, guys. Stop. Okay, right, so I stopped my Apache in host machine, so you don't see anything here. So now you have a base image. When you say Docker images, you have your custom image. Now you wanted to like run your image. Okay, so when you run your image, it will become a container. Now you wanted to bring up your own container, okay, from your custom image. Okay, so how to bring up a container from your own built image? So for that, sudo docker run, same command, guys. Okay, -it Apache 1.0 is your image. That's the same, right? Like how you provide for your Docker up images, right? Same way you have to provide it. Okay, and okay, if you want to give some name to it, you can -name equal to, say, like Apache server. Okay, something syntax is wrong. Is it -name? Let me check the syntax. What is the name of it? Hyphen hyphen name. Okay, it's not hyphen IT guys, it's a hyphen D, detachable. Okay, sorry. We have to provide docker run hyphen D detachable. Okay, name, is it a name? Yeah, name equal to something, Apache web server, and then finally you have to provide the image 1.0. Okay, so one is a name, one is your image name. Okay, this is a custom name guys, whether you provide don't provide, it's not a big deal, but you have to provide the image ID. Okay, image name and its version. And apart from that, so if you wanted to access your Apache server from host operating system, okay, it's nothing but it is running inside the container, the port 80. Okay, if you wanted to access it from your host operating system, what you're supposed to do it, you have to expose the port of 80 to external. So that is internal 80. Okay, now I want to expose to the external, which is from my host operating system. Let me explain you in the diagram, then you can understand much better. Guys, this is what my Linux machine. Okay, Linux OS, which is my host operating system. Okay, here what I did, I spinned off a small container. Okay, this is my container, Apache container, Apache container. Now in this Apache container, I am running Apache HTTPD on a port number 80. Now this port number 80 is running inside, but how do you know whether it is running inside or not? Okay, because no point in running within the container. I want to expose that to the external world. So you can expose that port to the external world, okay, at runtime, because a port can be exported, like in any service can be used from a container only when it is running. So when running, what you are supposed to do it, you can provide an option called -p. Okay, and on which port you want to export. See, external also, see, when I exposing to external, nothing but see the same thing you should be able to access from this machine. Okay, so what I'm trying to say is internally it is port 80, but when it comes to external from this Linux OS, what port you want to do it? I want to expose on same port. If you want to expose on same port, you can use 80. Okay, so now this one you can access from your laptop. Assume this is what your laptop. Okay, right, this is a CentOS hosting machine and your laptop, and if you want to access this container Apache from your laptop, you have to make use of this port, not the container port. Okay, because at runtime we expose this port, so most of the time we give same. Suppose sometimes, like in your host operating system the 80 is already occupied. Suppose in your host operating system the 80 port is already occupied, you cannot make use of the 80. So what you can do, you can change this port. Okay, you can change this port to some other port. So I'll show you the changing the port, but let's try to run with this 8080 only, the same port. Is it the syntax correct? -p. Okay, 80 80. Oh, correct. That's it. Now it's been started my container guys. If you want to check it out, sudo docker ps hyphen just ps. Is it running? No, it's not running guys. Let's see -a. What is the history? Okay, my Apache has been started and exited as well. So it seems like it is not running. The container is not running. It is spinned up and it's complete exited immediately. Let's see what happened with my Docker file. Okay, so this is starting actually. Okay, now what I can do it to avoid this problem, I'll put one more run statement. Okay, to start my image. Okay, this is to start. I'm sure there's something wrong if I try to provide both the commands in command. Okay, while true, copy. Let's see, it should go to infinite loop like this, so it will be hanging. Okay, or what I can do to instead of that, tail -f. This is also good. I can make use of the tail as well. Okay, so let's see, instead of while all this stuff, etc httpd logs sudo su. etc httpd logs access log. Okay, what I'm trying to do it, I'll try to tail this log file. Copy, exit, vi docker file, tail -f access underscore log. Does it have access underscore log? Yes. So let's try to spin up this, guys. Okay, so same build command, there's no change at all. Failed to get dbus connection, operation not permitted, returned a non-zero. No such file or directory. cd bin systemstl. Oh, where is it gone? Systemstl. Okay, so stop. This is working absolutely fine, so what is the problem? Sudo su bin ls system ctl. Okay, we docker file systemctl start. Just commenting it out. This, let's see. Build. Okay, this is successfully done. Docker ps-a sudo docker ps. Okay, that is not running. Now let's try to run that on a port 8080. You have to remove or rename the container. Okay, got it. So guys, once the container is running right with this image, we have to delete that. Okay, so or you have to run it with a different name, right? So remember, this is a regular practice. Docker ps-a. Can you see this? This has been stopped. Okay, now you have to delete this container first. ps-a, copy, sudo docker rm, paste. Now you try to build this. The name Apache server is already in use by 7e. Where do you see 7e? Okay, here it is. We deleted the wrong container. We need to delete the right one, guys. This is what your Apache server. Copy, paste. Now you try to build this. Okay, run this. Error starting userland proxy. Listen 80. Okay, already in use. Seems we are already running the Apache in our local with the port number 80. That's the reason it is failing. So we have to stop that. Stop httpd. Yes. Now you try to start this. Okay. What is error now? You have to remove. Okay, so we already started, right? So that's why it is failing. So we need to remove that container ID again. Docker ps-e. What is an Apache server? This is the one. Try to remove that. Sudo rm, paste. docker rm. Okay, now it's deleted. So try to run the build command, run command now. Okay, this is successfully running. So docker ps. No, it is not running, guys. It is again came out. Let me see, ps-e exited. Let me see the docker file. This is not going to work out. There is infinite loop block is there. Let me see. The while command only. I've written somewhere in my notes. While docker image docker container stopped after. So this guy is having the same problem. Let's see what is the solution they are given. Just use or something. Can you see this tail they are using? Okay, so we can also do that. It will keep your container running as long as you don't stop it, right? That's what we given. Let's try this with the tail. Okay, rm try to delete the existing container, guys. Copy, paste, build the container and run the container. Okay, now ps. Yes, this is up for 4 seconds, nothing but this is running. Now you can see your custom container Apache 80 is running, guys. Okay, so Apache 80 is running, and did you see this port? Okay, the internal port has been exposed to the external port 80. Okay, so now you should be able to, like, access the Apache. Now it's not running. I know why it is not running, because we didn't started the Apache. It's been installed. Okay, so if you look at the Docker file, see, I didn't started it. Okay, I commented the run command. So what you need to do, we need to start this actually. So let's try to start this. I don't use the run another run command. Instead, what I can do it, put a slash ampersand, second line, you can perform this start. Okay, now let's build this. Okay, it's rebuilding the image. Failed to get dbus connection, operation not permitted. Something wrong with this. Let's see any other way we can start Apache. Start httpd in docker container. Okay, how these guys are starting? cmd bin bash etc httpd start. Okay, okay, this is much better, guys, I think, compared to all of them. I'll take this, try to create a file called start.sh. Okay, put this etc init d. Okay, not init d. What is the command to start this? Start. Copy this, where is start.sh. paste. Okay. Right. Apache will start up startup, then container exits. I have tried a bunch of different CMD in my Docker file. Yes, we are also tried start.sh. However, every time Docker instance will exit. Yes. Any other workaround? Any other workaround? No, that's not going to work out, guys. Add this line at the bottom of your Docker file to run Apache. Sudo user has been httpd. Okay, this seems to be good. So the difference between entry point and command is, entry point is something like, once your entire image is built up, okay, it will run this command. Okay, you cannot pass any command from the runtime actually. So let's try to provide this entry point and see. Build we should remove that line actually. We didn't remove it. Okay, we didn't remove that actually. We had to remove this line. Go to the end. It is not starting with this line. And try to build it. It should be pretty quick. Okay, so docker ps -a sudo docker rm. Try to delete the existing one. Where is existing? Do we have existing here? No, I don't think it's run. Okay, now let's try to run this. No, seems to be existing is there. 1414. Did you see anywhere, guys? The existing container. Apache container. Yeah, here it is. Copy. Sudo docker stop. Try to stop that. Okay, because before removing it, you have to stop the container. Or there is one more way is there. If you don't want to touch that, you want to start your container, right? You put Apache server, right? You give another name, so it is a complete new container. See, it is started now. So if it is started, sudo docker ps, you can find your Apache server. Can you see this? Apache server 1, the new container. And let's see whether we could able to access the port number 80. Yes, this works now. Absolutely fine. Okay, so right now this Apache is not hosted on your machine, which is hosted on your container. Now you try to stop your container. Okay, stop your container ID is this, right? Copy and paste. Now you stop your container and try to access this. This is not accessible anymore, right? If you try to start it, okay, now you try to access your Apache. Yes. Okay, so what exactly I'm trying to say is, whatever the software deployment you're doing it, okay, you have to prepare an image, okay, and that image you need to deploy and run it. So you shouldn't worry about, like, what is there inside that image. So your job is here, like, prepare the Docker file. In this Docker file, you have to write the code to install what are all the things you required on that machine. Like, it can be Java, it can be Apache, it can be Tomcat, it can be MySQL, whatever. Okay, so it's our job to, like, prepare our own custom image, and this image we need to run it on your deployment server. Now you prepare a custom image, right? Now the next thing is, how do we store this image? Now this image is something like your jar file, guys, in your Maven. Okay, and where do you store your jar file, guys? Once you are done, typically we make use of a artifact repository, like, Nexus kind of a stuff. So similarly, for Docker also, we have a Docker Hub. In Docker Hub, you can create an account, okay, and you log in. So I have already an account in Docker Hub, guys. I'm trying to log in with that. So log in with your account. Anybody can log in. So you can push it to your account. You can push it to Docker Hub your images. Okay, so let me try to push that image into my account, guys. So to push that, first and foremost, what you're supposed to do, you have to log in. Okay, when I said Docker login, nothing but it will ask you username. Okay, my username is Chiranjeevi Patel. Okay, and the password is I'm typing the password, it is not showing there. Right, login is succeeded. Now I have successfully logged into my Docker Hub. Okay, from the command line. Now what I can do is sudo. Okay, before like pushing it to your Docker Hub, right, you need to tag an image. Okay, you need to tag an image. So what do you mean by tagging it? Like you need to point your image to the, like instead of a Docker Hub, to your respective repository. See, this Docker Hub is we call as a registry, guys. Okay, and these are all your repositories. Now we can push n number of repository your account. Okay, so let's see how to push it. So before pushing, we need to tag it. Sudo docker tag. There is a syntax is there. Let me check it out. Tag. Yeah. Before sudo docker images. Sudo docker tag. What is the image ID? What is your image ID, guys? Here, check it out. Apache image ID. This is what your image ID, right? Copy this image. Okay. Paste it. Now tagging. So what account? So my account is this one. Okay. And what name you wanted to push it? I want to push it with Apache, and its version is 1.0, like that. You can give anything. You can say latest also. Okay, now it's been tagged now. Okay, so once it is tagged, look at the sudo docker images. Did you see this? See, you already have a local Apache with this image ID, and you created another tag for the same container, same image ID. Can you see this B5F4? Okay, but only thing is you are pointing to your Docker Hub account. Okay, so Chiranjeevi Patel, and this is what my image name, and this is what my tag number 1.0, something like that. Okay, so now I can push it easily. Sudo docker push. Okay, and what do you do it? You just select this, copy, paste it. It's pushing this image to my Docker Hub now. See, what is the benefit of pushing is once you push, anybody can pull that easily. Suppose you are working on this one, so you want the Apache to be you want Apache image. Okay, so what you can do, you can pull the image with simply sudo docker pull, and this whatever the ID I gave it, right, that ID you need to provide, like my account name and Apache. See, it's pretty simple. If you remember, we downloaded from somebody else, right? Can you see HJD48 and Red Hat? Red Hat is his image name. Okay, and this is what his account name. Did you get it? So similarly, this is what my Apache image name is Apache, and this is what my account name. It takes a bit time, guys, because it needs to push so much of data, almost like a 1 or 3 MB image file. It is supposed to push it to your Docker Hub. Okay, so 20 MB is completed. So once it is pushed, you can find that Apache over here somewhere. Is it there, Apache, at the moment? Click on repositories, Chiranjeevi Apache. Yep, it is here. It's 3 days ago. It's a old one, guys. I pushed earlier. It should change the date actually if you push the same version. We can push it with a different name also. You don't have to worry about that. While it is going on, I can show you a couple of commands as well. So docker login, docker push. So if somebody wants, you can make use of a command called sudo docker pull. Okay, docker pull, and whatever image you provided, control C, control V. Okay, so if somebody wants, they can pull image. So once they pull image, how do you know whether it is pulled or not? You try to run a command called sudo docker images. You can see the list of images which are downloaded in your local. Okay, so this storage, whatever your storage you call this, okay, this we call as a registry in Docker terminology. Remember, it's a registry. In this registry, we have n number of repositories. This each and everything, each and everything you see rows, right? These are called the repositories. Okay, you might be a bit confused. So we have seen repositories in a source code environment different way, right? So here it is a bit different. So the Bitbucket or Bitnami you're seeing, right? You treat that as like a registry, and inside the Bitnami you created something like a repository. So those are like code repositories. Now each image is your one repository here. Okay. Hosting location. Docker Hub is one example. Okay. So your CentOS, Ubuntu, these are all your repositories. I need to explain you all. The most important thing is while writing Docker file. Yeah. So while writing the Docker file, you need to understand what are all these things. Okay. Try to read this. From we used in our Docker file, which is your base image. Maintainer, who is maintaining it. Run the Unix commands which you wanted to run it on your base image. Okay. You can have a number of run scripts. Environment. Suppose if you want to set some environment variable like a Java home, Topnet home, a Maven home, you can set the environment variables, and this can be like used in the upper layers. Okay, upper layers of your images. And command will be only one, guys. Okay, for entire Docker file we can provide only one command. This runs at the end. Okay, provides a facility to run commands at the start of the container. This can be overridden upon executing the Docker run command. So what exactly Docker run command? See, whatever the command you provide in a Docker file, right, that will be run at the end of the container comes up. See, once the container is coming up, right, there then it will start. This is what the first command. Okay, suppose if you don't write command, right, when you launch your Docker container, it will just launch and exit. It won't do anything. So that's the reason in a command I was looking to like write some infinite loops so that it will hang the container, it will not stop it. Okay. So add, what exactly add is, if you want to copy some file from your host machine to your container, okay, at build time when you're preparing an image, you make use of add. So how exactly we use it? Okay, this seems to be completed, guys. It's pushed to my Docker Hub. Try to refresh. Okay, can you see this? Chiranjeevi Patel Apache public one. Okay, 2 minutes ago. You can find the latest one. Okay, 2 minutes ago, and if you want to pull that, you can pull the Docker pull Chiranjeevi Patel Apache. This is how you can pull it. So this is what my Apache repository, and people can use this. They can download and they can run it. Okay, and again, now one image is running, right? I can launch another container with if sudo docker ps. Okay, already with the 80 port, it's already running this container. Okay, I can launch another container, run. Okay, only thing is what I will do it, the external port I'll change it, guys. 5000. It's my wish. I can use any port. Okay, external port nothing but my hosting machine port, and it is Apache's. I wanted to like run it with Apache server 2. That's it. Another container is started. Okay, if you want, you can cross check. Can you see with the port number 5000, internal is 80 only. Okay, it will not change because that's a we expose internally 80 port only, so we cannot change that. So 5000. So just check it out whether we could launch an Apache with a 5000 port or not. Yes, of course, we can launch. Look at this. Within an operating system, we launched two containers, and two containers are running the Apache, but in a different port. I exposed a different port. You cannot expose 80 again here, guys. If you try to expose 80 again, it will give a conflict because 80 external port is already open. Okay, so this is how you can expose a port. You can launch a number of containers. It won't take much time actually. But think about if it is a virtual machine. If you want to bring up a two virtual machines, how much time you spend? But here, in few seconds, you are bringing up a container and running the tools. Okay, that's easy it is with the containers. Yeah, I was talking about add, right, in a Docker file. In a Docker file, apart from maintainer, run, expose, entry point, and command, there is one more thing like add. Okay, what exactly add is, you wrote one file start.sh and you want to copy to this location in your see, this root is your container location destination. This is your current location where you are building it. Do you have a start.sh here? Did you see this? Okay, I wanted to copy the start.sh into my container. Okay, at this location, right? That's where you use the add, guys. Okay, suppose if you want to run some custom scripts, okay, you wanted to prepare that script within your machine and you wanted to run that in the container. Okay, so you can make use of the add. I'm not writing at the moment, and the same stuff we can use it you keep a war file here. At the runtime you want to deploy a war file in your container, so you can prepare an image like that. Okay, so whenever you are launching an image, right, so you should be you can bundle your artifact with an image and you can push it. I'll show you how to do that with a lead app application, but try to understand for today like how we are building the images and how we are running the images and how we are pushing to the Docker Hub. Okay, and if you want, you can pull the image from Docker Hub as well. I'll show you one pull command as well. So just look at this. I have multiple repositories here. Assume like there is a Fedora is there, okay, or Hello World is there. Let me try to download this Hello World. Okay, sudo docker pull Chiranjeevi, what is the full name? Chiranjeevi Patel. What is the name of the image? Hello World. Hello World. Sudo. It is sudo. Look at this. It's trying to pull the Hello World from the Docker. See, it's latest. Okay, it's the latest one. It is pulled. Let's see. Sudo docker images. Did you see that? Is it pulled actually? Tag latest not found. Okay, I think I didn't put a tag latest. I think I would have put 1.0. If you want, you can check it out. What is the version it is having? The tags. Yeah, it's 1.0. There is no latest. So try to provide the tag 1.0. Now it should download. See, it is downloading now. Right. So successfully downloaded images. You should be able to see that now. Can you see this Docker Hub Chiranjeevi Patel Hello World? Okay, it's successfully downloaded. I can spin up a container with this image as well. So this is all about the images concept and Docker file and how to push a Docker image and how to pull a Docker image. Okay, and what are all the component? I mean, what are all the code we write it in Docker file? So add command env run maintainer from. So these are the important ones. Okay, expose is the port one, and volume is also there. Volume nothing but you can copy like you can map a container directory to your host machine. Okay, nothing but in a container it is generating some logs, right? You can map it to your host machine as well. So that's called like volume one. Okay, if you will get a chance to look into the volume definition and how to use the volume. Okay, the most important things are the from, run, command. Okay, these are the most important stuff. Okay, most of the time when you're building the Docker images, right? So this is all about like how do you prepare a Docker. Okay, how do you like play around with the Docker containers and images. Now the next thing left is how do you like apply this container stuff to our lead app application. Nothing but, so what you are supposed to do it as part of now the technical stuff. Okay, now you need to convert this technical stuff into the project. Okay, so the lead app application is there. Okay, so you have to prepare two images. Okay, one image is for your lead app front end. Okay, lead app front end, and one image is for your lead app backend, which is nothing but this is your Tomcat server deployed and this is what your MySQL server deployed. So now what you're supposed to do, this image when you run it, it should bring up your web UI with the lead app. Okay, and this image when you run it, it should bring up a MySQL server. So how to prepare this, we'll see it in tomorrow's session. Mostly tomorrow we'll try to wind up. So if you could able to bring this application with the Docker containers, we are pretty good. Okay, any questions guys? I'm going to stop the session now. Any questions? Shashi, Vamshi, Mahinder, Kiran?
No.
Okay, good. So that's it for today. We'll catch up tomorrow. Tomorrow we'll write Docker images for our lead app application. Okay, see you all.